we're going to go on and use and study the law of cosines. So first off, we'll derive that law. The law of cosines. If you have a triangle and it's labeled as follows: A, B, C. So this is little c and this is little b, and here is little a. Now, if I break up little a, as I draw a line down and make a right angle. So this whole thing is little a. If I call that piece x, well then what's the balance? Well, if you have a, if a is this whole length, and you take part of it away, we take x away, well then what's left is a minus x. After all, what do you add to a to get x? Well, you have to add x and take away a. Okay, if you have a and you want to get x, you have to take away a. Now you have 0. Now add x. When you add these, you get x, because the a's cancel. Okay, you have to see it visually. You have to say, oh, I have to get rid of a and add x. Okay, that concept comes up a lot in word problems. Now, I'm going to call this line that I just drew H. It kind of split that original triangle up to 2 triangles. Triangle 1 and triangle 2. In triangle 1, I'm going to use the Pythagorean theorem. Remember, here's a right triangle, so that's the hypotenuse. I have x squared plus h squared equal to b squared. And in the second triangle, C is the hypotenuse. I have a minus x squared plus h squared equal to the hypotenuse squared. Okay, now I subtract mainly to get rid of h. H squared minus h squared is 0. So I have x squared minus a minus x squared is equal to b squared minus c squared. Okay, let me clean up the left side. X squared minus a minus x squared is a squared minus 2 times ax plus x squared. Well, x squared minus x squared, that cancels out. So I have minus a squared and minus negative 2ax, which is plus 2ax. That's the left-hand side. And this is equal to the right-hand side, b squared minus c squared. Okay, so I want to get c squared alone. I'm going to bring the c squared over to the left side, and everything goes to the right side. So I dealt with the c squared. I'll deal with the a squared now. When I bring it over to the right side, it becomes plus a squared. The b squared stays as plus b squared, and the 2ax comes over as minus 2ax. Now, I'm 90% done. I want to know what x is. So I'm looking into, I guess that didn't come out so well. I'm looking in triangle 1, the left triangle. And if you compute the cosine of c, the cosine of angle c is x over the hypotenuse. And the b can come up here. This is another way of writing x. And I'm going to put that right there. So I'm going to recopy this, but where I see x, right there, I'm going to write b cosine c. So c squared is equal to a squared plus b squared minus 2a and x times x. So x is b cosine C. Here is one form of the law of cosines. Okay, there are two others. Let's list them down, and we'll have the law of cosine formulas in front of us. So we have that c squared is equal to a squared plus b squared minus 2 times this times that times the cosine of that letter. Now, c squared didn't have to be on the left. I could have had b squared on the left. But here I have a squared plus c squared. Remember when I had my triangle, I drew the line that way? I could have drawn it this way, and that would have just switched the letters around. Minus 2 times this letter times that letter, AC, times cosine of big B. I could have had A first. A squared equals B squared plus C squared, the other two letters, minus 2 times BC times cosine of big A. There are the law or cosines. Now, I want to talk about the angle that we are taking the cosine of. Okay. If this is little a and this is little b, well, that means that must be angle A, and opposite B must be big B. The angle in the middle of A and B is C. The angle in between A and B, that's the angle we're taking the cosine of. The angle in between A and B, that's what we're taking the cosine of. What about A and C? We can draw the same triangle. Here's A and B and C. Between A and C, that's this angle here. This angle B. And after all, it is opposite little b. AC, take the cosine of the angle in between. If you have B and C, if this is B and this is C, well then this must be angle A. Why? Because that's angle B and that's angle C. In between is angle A. So this angle is always in between those two sides. Okay, that's important to see, because when you have two sides and the angle in between, then you can use the law of cosines to find the third side. Let's look at that again. If you have b squared is equal to a squared plus c squared minus 2ac cosine of not A or C, but B. Well, if you know A and C and the angle in between, big B, well then you can compute A squared, you can compute C squared because you know A and C, you can compute 2 times AC, and you can compute cosine of B. That is, you have the whole right-hand side. You have the whole right-hand side. So if you know the right-hand side is 25, then you know what B is. It's the square root of 25 or 5. Okay. So, I'm going to give you some information, and we're going to be asked to complete their triangle. Find all the information. And we'll probably use the law of sines. I meant to say the law of cosines. Okay, so we have this triangle like such. A, B, C. A is 35 degrees. This is 20. This is 10. find x. Find x. Well, this is not a sine problem because we have our pair here, a side and an angle, where the side is what we want to find out. But we don't have another pair. We have this side, but we don't have that angle, nor can we calculate it. Like if we knew what angle A and angle B were, we can find angle C. But we don't know what angle B is. We know what little b is, but we don't know what angle B is, nor can we calculate it. But here's what screams to use law or law or cosines. You are giving two sides and the angle in the middle. And you're asked for the third side, which is called little a. You want to write x squared equals, fine. I'll write a squared equals. A squared is equal to b squared plus c squared minus 2 times the product of those two letters times the cosine of the angle in between. That is that letter, big A. All right, so opposite angle C is little c, and opposite big angle B is little b. So we have b squared, 10 squared, plus 20 squared, minus 2 times 10 times 20 times the cosine of 35 degrees. I mean, you can just type this right into your calculator. You can hit 10 squared, your calculator will say 100, plus 20 squared, I'll say 400, minus 2 times 20 is 40, times 10 is 40 with the 0, times the cosine of 35. The cosine of 35 degrees is approximately 0.8192. But really, you should just type it in like this. You should not write down anything but the final answer. I would just type in 10 squared, the square button, plus 20, then the square button, minus 2 times 10, the times button, 20, the times button, the cosine button, 35, and then your equal button. And I get 172.3392. This is 172.3392. Let's see if that makes sense. 380, yeah, that makes sense. Okay, so now, so that's what a squared equals. So now you take the answer and you take the square root of it. The square root of the answer. And in your calculator, you have this to make most probably more than 4 decimals. So just take the square root of that answer. You have a button most probably on your calculator that says answer. In my calculator, I hit the square root button, and then I hit the button that says answer. Since the button in my calculator that says answer is in yellow, first I hit the yellow button. But that's really calculator dependent. And when I do that, I get that A is 13.1278. So we have A. That is, we have X. 13.1278. We use the law of cosines to get it. Why is this the law of cosines? Because we only are using cosines. You won't see your sine in these problems. And if you do, either you're using the law of sines and didn't realize it, or some other formula you're using. There are definitely trig formulas that use both the sines and the cosines. given two sides and an included angle, or three sides, you should use cosines. For example, if you're told this is A and B and C, and you're told that this is 98 degrees and 10 and 16. 10 and 16, and they ask for X. You're given two sides and the angle in between, and they're asking you for the third side, which, by the way, is called A. Use lower cosines. Start off with A squared. A squared is equal to B squared plus C squared minus 2 times those letters times the cosine of big A, or what's in between B and C. Let's see, this is little b, and this is little c. What's in between B and C? What's right in the middle? Angle A, which is always going to be big, that letter, big A. And we have B is 10 and C is 16, 2 times 10 times 16 times the cosine of 98 degrees. I would just copy this in completely. I would first hit the 10 button, and then your X squared button, and then your plus button, and then 1/6, and then your square button, and then your minus button, and then 2, your times button, your 10, that is 1/0, your times button, and then 1/6, depending upon, well, you can always hit times. Some calculators you don't even have to. Then you hit cosine. On my calculator, it gives you the open bracket. You should then type in 98, and then hit equal, and you'll get your answer. And then take the square root of that. Okay, then take the square root of that, because you don't want to know what A squared is, you want to know what A is. Okay, 10 squared plus 16, the square button, minus 2 times 10 times 16 times cosine 98 degrees. Make sure I did that right. I sure did. Which is amazing. And I get a drop over 400. So A is 400.5353923. So then A, or X, will be the square root of that. So I hit my square root button, the square root, and then I hit the answer button. That gives me, that puts under the radical the answer to the previous line, which was this. Not even rounded off. Normally I round off to 4 places. I won't even use the rounded off version. And I get that A is 20.0134. That's 8 or 4 decimal places. Problem is done. Law of cosines. Now sometimes they'll give you 3 sides and ask you to find the angle. Sometimes I'll give you 3 sides and ask you to find an angle. Now here you have to decide which is their included angle. For example, if I tell you 3, 4, and 5, and I ask you to find X. Okay? So what you should do is say, so, maybe this is A, and this is B, and this is C, so that's big C, big B, and big A. since they want cosine of c, you should start off with c squared is equal to a squared plus b squared minus 2ab. Here's the reason, cosine of that letter but big. Why do I say that letter big but big? Because that is little c. We want cosine of big C. The angles are big letters, the sides are the little letters. So we want this. Well, now you can solve for this. That is, let's solve for this term first. Let's bring this over here and bring this to the right. To the left, I'm bringing this over because it's negative. When I bring it over, it'll become positive. And the right side dealt with this. The right side always had a squared plus b squared. And now when I bring the c squared over, it becomes minus c squared. And now I can divide by 2ab. The 2's cancel, the a's cancel, the b cancel. So then I get cosine of c. And on the right-hand side, of course, I divide by 2ab. So what you can do is in brackets, you can say a squared plus b squared minus c squared. All of this divided by, in brackets, 2ab. Let me do this up here. So cosine of c is equal to a squared, a is 4, a squared plus b squared minus c squared, close the brackets, divided by, in brackets, 2 times a times b. Okay. The reason you need the bracket, let's just say for argument's sake that was 100. If you do 100 divided by 2 times 4 times 3, it will do 100 divided by 2, which is 50, times 4, which is 200, times 3, which is 600. But that's not what you want. What you want is 100 divided by, I think, 24. Divided by 24, which is less than 100. This answer was 600. Okay, so you have to put the brackets. Now that will tell us exactly what the cosine of c is. If you want to be real slick, you should say, you know what? Let me interchange this with this. It is just compute the cosine inverse of what's in this bracket. But that's getting carried away. Let's figure out what's in that box. We'll call it cosine of c, and then we'll solve for c. So cosine of c equals, okay, it's 4 squared plus 3 squared minus 5 squared. And all of that gets divided in brackets by, I mean, you can just say 24 if you like, but you need to work it out. 2 times 4 times 3, and you get 0. The cosine of c is 0. Sometimes you should know things. Remember, this is a multiple. This is 0 or 1, and we know the cosine graph. We know the cosine graph. Now remember, an angle, c is an angle. It never goes more than 180. So you can even ignore this portion of the graph. We're just going up to 180. It's here is 0, and like I said, here is 180. Right there where it equals 0 is 90. Cosine of 90 is 0. If you don't know that, or if you don't want to know that, the cosine inverse is 0. If you type that in, you'll get 90. How did I get this line? I interchanged these two. C is equal to the cosine inverse of 0, which is 90 degrees. Okay, so we now know C is 90 degrees, that is X is 90, and we should say, wait a minute, 90, we should be able to check that. We should be able to check that we're right. If C, or X, we called it X, is 90 degrees, well, then we have a right triangle. C is 90, B, A, this was 4, and this was 3, and this was 5. If it's a right triangle, Pythagoras' rule should work. It's 3 squared plus 4 squared, 5 squared. The answer is yes. If you notice that from the get-go, then you know that this was 90 degrees. Opposite their hypotenuse is 90 degrees. Opposite the larger side is the right angle. If it is the right triangle. If I tell you that the triangle I'm about to draw, little a is 4, and little b is 7, and little c is 10, if I tell you it's a right triangle, if it is a right triangle, right there, then 10 must go there. Where you put a and b, they can switch. That is, you could have put b equals 7 here, and a equals 4 here. Okay, and no, this is not a right triangle because 4 squared plus 7 squared is not equal to 10 squared. But if it did, if it were a right triangle, opposite the largest side would be the right angle. And it does turn out, even though I put a plus sign there, it does turn out that 3 squared plus 4 squared equals 5 squared. That is 9 plus 16 really is 25. 9 plus 16 is 25. So it did check, and what does it mean? It means that we were correct when we concluded this was a right triangle. In the other problem, they weren't right triangles. So if you took the smaller side and squared it, and then added on the middle side squared, you should not get the larger side squared. That only happens with a right triangle. Okay. One last thing I want to point out is what happens to the lower cosines if their angle is 90 degrees. And if we have a squared is equal to b squared plus c squared minus 2bc, cosine of angle A, but angle A is 90 degrees. The cosine of 90 degrees, well, here's 180, I mean that was halfway. Here's 180, here's 90, it's 0. This is 0. 2 times b times c times 0 is 0. So you get a squared is equal to b squared plus c squared minus 0. Don't even bother taking away the 0. You get the Pythagorean theorem. Now, if you're going to say, oh no, Pythagorean theorem is c squared equals a squared plus b squared. Well, I mean, that's alphabet soup. If I tell you this is the right triangle, yes, if this is a and this is b and this is c, then absolutely. C squared is a squared plus b squared. The hypotenuse squared equals one leg squared plus the other leg squared. But this doesn't matter what I call them. If I call this A and this B and this C, and I say right triangle, that's the hypotenuse. The hypotenuse squared equals one leg squared plus the other leg squared. That's the Pythagorean theorem. It's not c squared equals a squared plus b squared. suppose you have this setup. Suppose you have these two boats. You have this boat and this boat. They are moving to the right, and they are always 120 feet apart. 120 feet apart. And they're pulling a third boat. They are pulling a third boat. By a rope. This rope is, say, 230 feet. Not degrees, 230 feet. And this rope to that boat is a little bit shorter, 212 feet. The question is, what's that angle? Two ropes meet right where it hooks up to the boat. What is that angle? Well, you have three sides of a triangle, and they're asking, so let's label them A, B, and C. So then this here is big A. It's opposite little a. We want to find big A. So start off with a squared. A squared equals b squared plus c squared minus 2bc cosine big A. Swap this with this. So 2bc, because it's negative, I bring it over, it becomes positive, bring it over to the other side, is equal to b squared plus c squared. And bring the understood plus a squared over is minus a squared. And I do have a typo. I didn't bring everything over to the left as promised. I need to bring over 2bc cosine a. I brought all of this over. And now I divide by 2bc. Divide by 2bc. And this cancels out. So that's where cosine A equals. Cosine A is equal to 212 squared plus 230 squared minus A squared, which is 100 squared. And all of this gets divided by 2 times B times C. Let's see what that equals. The big numbers, 212 squared plus 230 squared minus 120 squared. I should have said put that all in brackets, and then divided by, in brackets, 2 times 212 times 230. Close the bracket, execute in my calculator. So we now know what cosine A equals. It equals to 0.8557. That's what cosine A equals. That A is the cosine inverse of 0.8557. So now that number, this number before we rounded it off, that should be in your calculator. So hit cosine inverse and then type in answer, or hit the answer key. And I get 31.1672. And you can, and that's rounded off. You can take the cosine of that answer in your calculator, hit cosine answer. And you should get the 0.8557 number. And I am. Okay, that's law of cosines. Use the law of cosines if you're given two sides and the angle in between, and they ask you for the third side. If they give you side B and C, and they also give you angle A, and they're like, what is little a? Law of cosines. Or if they give you all three sides. They give you all three sides, then they ask you what A is. Or if they give you all three sides and they ask you what B is. Or of course if they give you all three sides and they ask you what angle C is. Those are law of cosine problems. Anything else? Law of sines. Alright, good luck with these laws.